There are also some word problems in 10.6, some compound interest problems. Some of them are compound continuously, and some of them are compounded different time periods like quarterly and monthly. The compound interest formula is A equals P times 1 plus R over N to the NT power. A is the amount after T years have passed. P is the principal. R is the rate. N is the number of times per year compounded. T is the number of years. Remember that quarterly would mean 4 times a year. Monthly would mean 12 times. Daily, 365 times. Annually, 1 time. Biannually would be 2 times per year. The other formula that we need to use is when they're telling us that the interest is compounded continuously. Compounded continuously, the formula is A equals PE to the RT. A is amount after T years, P is the principal again, E is that key on your calculator, R is the rate, and T is the number of years. Let's look at the handout that you printed off that I sent to you that says, how much money will there be in an account at the end of 5 years if $1,000 is deposited at 6% compounded quarterly? We know we're going to use the first formula because it tells me how many times per year it's compounded. When it says quarterly, that means 4. I'm going to substitute 1,000 for the principal, 0.06 for the rate. 4 goes in both of those places where I have those ends, and it's for 5 years, so that's 5 right there. You have to put your exponent in parentheses. You put that in your calculator just like you see it. You have 1,000, open parentheses, 1 plus 0.06 divided by 4, close parentheses, housetop, open parentheses, 4 times 5, close parentheses, $1,346.86. Round it to 2 decimal places because it is money. Number 19. How much money will there be in an account at the end of 6 years if $4,000 is deposited at a rate of 3.5% compounded continuously? When you see that word continuously, that tells you you're going to use that second formula. That formula is A equals PE to the RT. A equals, my principal is 4,000. E, the rate is 0.035. We're leaving it in there for 6 years. We're just going to put that in our calculator. 4,000. Second divide gets that E in there. Housetop, open parentheses, 0.035 times 6, close parentheses, and we have $4,934.71. $4,934.71. Number 21. How much money must be deposited today to become $1,850 in 40 years at 6.5% compounded continuously? We know we're going to use this because we see that word continuously. Substitute your values in there. It's saying how much must be deposited today. So I'm looking for P. P is what I'm depositing today to become $1,850 in 40 years. So 1,850 equals PE to the 0.065 times 40. I want to divide both sides by E to the 0.065 times 40 because I'm trying to solve for E. I don't have to do anything weird. I'm just dividing by this. It just sort of looks funny. When you put that in your calculator, put it in just exactly like you see it there. $1,850 divided by E, housetop, open parentheses, 0.065 times 40, and you got $137.41. So if you deposit $137.41 today, and you leave it in there for 40 years at 6.5%, in 40 years you'll have $1,850. An extra problem that you need, because there are some homework problems that look like this, and I think there's one on the test that looks like this. How long would it take $4,000 to double if it's deposited at 3.5% compounded continuously? That tells me that I'm writing down that second formula because I see that word continuously in there. How long would it take $4,000 to double? Well, if it doubles, it's going to become $8,000. The rate is 0.035. I don't know T. Step 1 is to divide both sides by 4,000. 2 equals E to the 0.035 T. I'm solving for a variable that's an exponent, so I have to take the log of each side. That's why we learned how to use these logarithms. So, and also since I got an E in there, I got to take the natural log. Natural log of 2 equals 0.035 T times the natural log of E. We know natural log of E is 1. I can just cross it out. Divide by 0.035 on each side. Whenever you put that in your calculator and work that out, you should get T equals 19.8 years. Let's put that in the calculator and be sure that's what we get. Natural log of 2, close parentheses, divided by 0.035 comes out to be 19.8. This should take care of everything you need for lesson 10.6. If you need help on some of these problems, either call or text me.